Hello and welcome to another of Camp's C++ Quickies. Today we're going to be talking about uh, arrays in C and C++. Um, Note that this is very slightly different from how arrays work in Java and C Sharp. So if you're watching this video to learn how to do those, you'll have to modify what I teach you a little bit. Um, Most of it works the same, but the declaration is sort of backwards from how it works in C and C++. Okay, so a little motivation. Why would we want to use an array? Well, let's say it's 2020, COVID-19. You want to track the running total of cases in your area over the last few days. Um, well, you can say int cases day one, int cases day two, int cases day three, and you can keep doing that. Dot, dot, dot. Okay. Until you got to int cases day nine and int cases day 10, or maybe you want to do it for a whole month. So that would be day 30 and cases day 31. Now, if we wanted to know how many new cases there were, we'd have to know which 2 days we were talking about. So we could say cout new cases day 2 equals cases day 2 minus cases day 1. But if we wanted the user to pick which case, which day we wanted to know about, we'd have to write a whole series of if statements to say if it's day 5, then use day 5 minus day 4. If it's day 7, use day 7 minus day 6. You can see how this gets terribly inconvenient very, very quickly. What if there was a way to store all of these values in a single variable all at once? And obviously there is, or I wouldn't be doing this for you. Okay, so the way to do that is to use a variable called an array. Okay, so where normally an int type variable points to one box in memory that holds the number, say, 3,424, or 309.24 is how I wrote that. Maybe that's how many cases there were on day 10, 3,924. The array cases is going to point to a long chain of memory boxes. Okay, so you have that one, and 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 that one. And they keep going to the size of your array. You have to set a specific size for an array. They can't go on forever. But let's say on day 1 there were 10 cases known in Houston, and on day 2 there were 16, and then there were 24, and so forth and so on. Now, the variable cases does not point to this entire array. What it technically does is it points to the location of the first memory box. And to refer to that first memory box, okay, we would say cases square bracket 0 square bracket, and that's pronounced cases at 0. Okay, and that indicates to an offset of 0 places from the start of the array. Okay, arrays, very important to know, are what we call zero indexed, which means that the first member of the array is known as position 0, and that's because you'd have to, starting with where the variable cases points to, you don't have to go anywhere. Okay, if we wanted this one, we have to go 1, 2 hops to get there. So this one would be cases at, or cases subscript, it's sometimes said, 2 would point to that number. Okay? So that's the theory. Let's see how it works in code. Okay? We would define want an array to hold up to 31 integers representing number of cases each day. Okay, so we declare that it's type int. Okay, cases is what we're going to use for the name of the variable. Some people will add the word array, make it case array, to remind themselves that this variable is an array type variable. Other people will just make it plural, and that reminds them that this is not just one number of cases. This is all the cases. And then we put in square brackets how many we want cases to hold. Okay, that's the minimum you need to do to define an array variable. And then we can go through and say cases at 0 equals, what did we say it was, 10 on the first day. Cases at 1 is 16 on the second day. Cases at 2 is 24 on the third day, and it grows, exponentially from there because it's a virus. It does that. So we could sit here and type in all of those values. There are other ways to do this. One of the handy things about using a array is that we can access each box in the array programmatically. So if I wanted to fill in all these cases, I could say for I, in this case, means index 0 less than 31 I plus plus. That's if we're in a month of 31 days. Okay. Maybe we have a variable somewhere called days and month that would let's say this is February on a non-leap year, it would be 28. Currently it's October, so we know that there are actually 31 days. So you would have to set that somehow. Now I can say see out how many cases on day I plus 1. Okay. And you might ask, why am I doing I plus 1? Well, remember, the array is indexed at 0. So the first day in the month is day 0. The last day in the month is days in month minus 1. So, but people don't think that way. We think of the days in a month as starting on day 1 and counting up to day 31 or 28 or however many days in the month. So we have to add 1 to I to make it human readable. So I'm going to read in CN cases at I, and so this will take me through all 31 days and let someone, some poor schmuck doing data entry, type in all of those cases. I could also read them from a file if I wanted to. Your textbook has an example of reading numbers from a file. You would create a file input instead of CN, and you would do essentially the same thing here, except you wouldn't have to prompt how many cases on day which, you'd just keep counting up. Okay. And the nifty thing about using an array is that this way I can say C out which day do you want to know new cases for? Okay. CN new day. Obviously, it's going to yell at me because I didn't declare new day, right? Okay. CN new day, and then C out. See, how do we calculate this? It would be cases at new day minus 1, because again we're 0 indexed, but the person thinks in one indexed numbers, minus cases at new day minus 2. That brings us back 1 day. Okay. New cases on day new day. End line. Okay. So I'm going to run this sample program with only 10 days in the month because I don't want to have to sit here and type in 31 whole numbers. So let's say cases on day 110. Let's say we have perfect exponential growth. So next day would be 20, then 40, then 80, then 160, then 320, then 640, then let's say it slows down at this point, 1,000, 1,500, 1,850. Okay. Which day do I want to know new cases for? I want to know day 8. So it should, if this works correctly, take 1,000 and subtract 640 and get me 360. 360 new cases on day 8. See? It did what it was supposed to. Okay. Couple of notes on this. A lot of people don't like the style of putting a magic number in the brackets here. They would rather have that be a named constant. Okay, so I could say const int max days in month equals 31, because we don't have any days, any months with fewer than 31, I mean more than 31 days. And so I can now drop that integer in here, and voila, I've got exactly the same result. I've got a 31 size array, but now if I ever want to output my whole array, um, I could drop max days and month in here, and it will step through the entire array at once. Okay. Another way that you can set up an array is if you happen to know how many cases, you can skip this whole input array if you happen to know all of your data in advance. You don't even have to put anything in the brackets if you're specifying the data. We can say 8, 16, 32, 64, 128, to all the powers of 2 here, 256, 512, 1024. Okay, how many days is that? I don't know, but I don't have to tell it. It can count. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to build me an array of size 8. Okay. What if I want more room than that? Well, I can actually do what's called partial initialization. It will fill up the first 8 slots with this information and then initialize the rest of the array to 0. So I'll still have a size 31 array, but it'll only have 8 values in it to start with. Okay, so those are all some fun tricks you can use to set up your array in advance. You can, two key things to note, you can only do this at initialization. Okay, you cannot come down here and say cases equals 1, 2, 3, 4. That does not work. Okay, that will not compile. It'll come here and it'll tell me too many initializer values, and yeah, and that this must be in a valid L value, left side value. Now, what I can do is say cases at 0 equals 2. Okay, but I then have to go through and specify each one individually that I want to set. So you can only use the initializer list when you first create the variable. Okay, and of course, you can also only use cout and cin with individual units from the variable. I can say cout cases at 4 cases on day 5. Okay. But I couldn't do cout cases. Okay, some programming languages, I think Java has a way that you can print an entire array on one line by doing something like this. C++ does not allow that. You have to step through the whole array one thing at a time. Finally, last note on arrays, one thing you can do with an array that you can't do with any other type of variable in C++ is you can step through it automatically with a special for loop known as a range-based for loop or a for each loop. Okay, and I can use the keyword auto to say, pick the appropriate variable type. and I can call it var if I want for variable, or each, or something, or I can say case. Well, I can't. Case is a. Um, I can say day. Okay, so I can pick day from cases. So what this does is it says pick day from cases, run the loop, pick the next day from cases, run the loop. Okay, we're going to step through automatically. See out. Um, day cases inline. What do you think this is going to do? It's going to go through days in the month one at a time, and if this works correctly, we'll have 8 on one line, then 16, then 32, etc. So let's see if this is what it does. Okay, we got 8, 16, 32, 64, 128, 256, and then remember we had created all that extra space in the array that we had initialized to 0. So it outputs those for us too. Okay. If we want to modify the array, we put an ampersand in front of this, and we say day plus plus, say. Okay. And then okay, let's see if this works. It should increment all of our days. And yeah, so we now have 9, 17, 33, etc. until we hit the zeros, which all got incremented to 1. Okay, so that's how you use the range-based for loop, or also known as a for each loop in C Sharp. Well, in Java, the range-based for loop works exactly the same way, except you don't have the ampersand operator. In C Sharp, the loop is actually called for each and has a slightly different syntax. It's for each variable, for each var day in cases is how you would put it in C Sharp. Okay, that's it for general arrays. We're going to come back in just a minute and look at doing the same idea with vectors.